Hello everyone, my name is Ogeneti Mamogo and you are welcome to Upscale Academy. Now if you are new to my channel, feel free to hit the subscription button below. Also like, share, and of course avail yourself to the lesson so as to be carried along. Welcome back. So in today's lesson, we're going to be talking about Dalton's atomic theory under the broader topic, particulate nature of matter. We began this topic in our last lesson. If you're here to watch that video, please feel free to check it on my channel. It is titled Particulate Nature of Matter, Physical and Chemical Changes. First things first, what are atoms? According to Demetrius described atoms as being very small particles, so small that they cannot be seen with the naked eye. So atoms are actually really small. Okay, so that's one thing you should know about atoms. They can't be seen with the human eye. But when we talk about definition of an atom can be defined as the smallest particle of an element which can take part in chemical reaction. So an atom is the smallest particle of an element which can take part in chemical reaction. Now, it was previously believed that atoms were actually indivisible. Indivisible means that they cannot be divided. But due to recent discoveries, it was later found out that atoms can actually be divided into what we now know as protons, neutrons, and electrons. So atoms are no longer indivisible. That is why we define atoms as the smallest particle of an element which can take part in chemical reactions. It was also previously thought that atoms could not be created or destroyed, but recent discoveries have proven that otherwise. We're going to be talking about some of these changes, some of these modifications. So we're going to be discussing John Dalton's atomic theory, and we're also going to be discussing the modern modification of his theory. Okay, so we're going to be comparing them side by side so that we can observe the changes that this theory has undergone over the years. I hope that is okay. So very quickly, we're going to be running through the main ideas behind John Dalton's atomic theory. So we're going to be taking them side by side for comparison's sake. First things first, under John Dalton's atomic theory, number one, all matter is made up of tiny particles called atoms. So all matter is made of, remember we said that matter is anything that has mass and occupies space. So all matter is made up of tiny particles called atoms. So matter consists of atoms. So this fan is matter. Why? It has weight and it occupies space. Okay, so your book, your chair, your table, these are examples of matter. Okay, it's not only elements, right? So even the things that we see at home, our houses, they occupy space, they have weight. So these are what we refer to as matter. So we say that all matter is composed of what? Tiny particles called atoms. So that is the first theory put forward by John Dalton. Okay, now for the modification, it was later discovered that atoms are no longer indivisible. Indivisible means they cannot be divided. Okay, so it was found out that atoms can actually be divided into protons, neutrons, and electrons. So that was the modification of that theory. Atoms are no longer indivisible. They can actually be divided into protons, neutrons, and electrons. So that's the first theory. The second theory is this: atoms of a given element are identical both in mass and chemical properties. So atoms of a given element, for example, let's say chlorine. So chlorine is an element, okay? So atoms of chlorine are identical both in mass and chemical properties, meaning that chlorine has the same atom. All atoms, remember we said that matter consists of what? Atoms. So chlorine is matter. Why? Because it has weight and it occupies space. So chlorine consists of atoms, right? And this theory is trying to explain that all atoms present in chlorine are identical both in mass and chemical properties. So chlorine has a mass number of 35.5, meaning that every atom that is present in chlorine also has a mass of 35.5. So atoms of a given element are identical. Identical means the same, both in mass and what? Chemical properties. So that is for John Dalton's theory. Now for the corresponding modification, it was later discovered that atoms of a given element may have the same atomic number but different mass numbers. Remember, in the previous theory, atoms of the same element or of a given element have the same mass. But for the modification, it was later discovered that atoms of a given element may have the same atomic number but different mass number. So this was what bettered what we now know as isotopes or isotopy. So I'm going to be defining very quickly what isotopes or isotopy is. So what are isotopes? Isotopes are elements having the same atomic number but different mass numbers. So they have the same atomic number but different mass number. An example of this is carbon. So we have carbon 12, we have carbon 14, and we have carbon 16. This is what we refer to as isotopes. Carbon has an atomic number of 6, okay, but these isotopes have the same atomic number of 6 but different mass numbers. So this is what we refer to as isotopes. And then isotopy is the existence of these elements. So isotopy can be defined as the existence of an element having the same atomic number but different mass number. I hope you understand that. So it was because of recent discoveries that we now it was later learned that atoms of the same element can have what? The same atomic number but different mass number. So that is the modification of the theory that said atoms of the same element have the same mass. I hope we understand that. So moving on to number 3. Number 3 theory was this: atoms of different elements have different mass and different chemical properties. So don't confuse it with number 2. Number 2 was atom of the same element have what? The same mass. But number 3 is telling us that atoms of different elements, for example, oxygen and chlorine, okay, these are different elements. So this theory is explaining that atoms of different elements have what? Different mass and different chemical properties. But due to recent discovery, it was later found out that atoms of different elements may have the same mass numbers. So this is what bettered what we now know as isobars. Okay, isobars are elements having different atomic numbers but yet the same atomic mass. So isobars are elements having different atomic numbers but the same atomic mass. Okay, so that is the modification of number 3. I hope we are taking note of these differences. I hope we are jotting down. In my experience, it is much easier to retain things you learn when you jot down. So that is number 4. Atoms of different elements may have what? The same mass. So that's number 3. So number 4, under John Dalton's theory, atoms of different elements combine in simple whole numbers to form compounds. Atoms of different elements combine in simple whole numbers to form compounds. Okay, an example of that is water. But first things first, what are compounds? Okay, compound is a combination of 2 or more elements chemically joined together. So these are what we refer to as what? Compounds. Remember, we just said that atoms of different elements combine in simple ratios or simple whole numbers to form compounds. And now we have just learned that a compound is a combination of 2 or more elements chemically joined together. So that is that theory. That theory was trying to explain that atoms or elements combine to form what? Compounds. An example of that is water, H2O. Okay, that's an example of a simple compound. But recent discovery proved that atoms or the manner in which elements combine may not be simple. An example of that is glucose or sugar. So we have carbon 12, hydrogen 22, and oxygen 11. Okay, so you see that ratio is not simple. It's not as simple as 1 and 2. So we have 12, 22, 11. Okay, so that theory was now trying to explain that the manner in which elements combine may not be simple. Okay, so that compound is an example of a complex compound. Okay, so that is what that theory was trying to explain. I hope you understand. Okay, then for number 5, which is the last of Dalton's atomic theory, Dalton previously taught that atoms could not be created nor destroyed. Okay, so atoms could not be created nor destroyed. But recent discoveries have proven that atoms can actually be destroyed, but only during the course of a nuclear reaction. So atoms can actually be destroyed, but only during the course of a nuclear reaction. So these are some of the ideas put forward by John Dalton. Okay, so John Dalton based his theory on the law of conservation of mass and the law of constant composition. I hope we have been able to understand the theory and then the corresponding modification. Please, if you have any question concerning this topic, feel free to drop it in the comment section below. Also, if you have other comments as pertains to this topic, feel free also to drop it in the comment section below. So with that, we're going to be concluding today's lesson. I hope you enjoyed this topic as well as I did. Till next class, I remain your tutor, Ogenetiji Omomogo. Have a wonderful day.